Dear children, today let us see the introduction to the new unit, that is probability. So before going to enter the definition of a probability, let us see some day-to-day life situations. So the first situation is that it may rain today. So if anybody tells that it might rain today, we are not sure that whether it will rain or not rain. At the same time, as India has scored well, it has a lot of chance to win the game. So here we have used the word it has a lot of chance to win the game. So even if it is having a lot of chance to win, but cricket is a game of unpredictable. So we are not sure that whether the India can win or not. Next example. Most probably because of his hard work, he can qualify the physical. So here we have used the word most probably. It means what? Because even he has done a lot of hard work, it's not sure that whether he can qualify for the physical. See, the above all situation in day-to-day life, what we have observed, it tells about the uncertain things. Here uncertain things means we are not sure about its occurrence. We are not sure about its occurrence means we are unable to tell that whether it is surely going to happen or not going to happen. So these all above situations, there is a uncertainty about the occurrence of the event. We are not sure that whether this is going to happen or not, as we have seen the three situations, that is it may rain or not. The India, if it has scored well, even though it doesn't have a, definitely we can't say that it may win. And even if a person has been worked lot and he might be qualified the physical or not. So these all uncertain things we are unable to predict, but in the field of mathematics we can tell that to how much extent that event can occur. That's what we are going to see in the probability. So this certainty can be measured mathematically, that is to how much extent that event can occur. So here are the things we have seen, that about these all three situations, they are uncertain and we are unable to predict, but in the field of mathematics we are able to tell that to how much extent we are able to that the event is going to occur. Let us come to the definition of probability. Here it is. It's a branch of mathematics which deals with quantitative. Quantitative means in which we say that it is in terms of number. Quantitative measurement of uncertainty. So about uncertain things, to how much extent that event can occur, we are able to tell by numerical. That's what we are going to see in the probability. That's what we mean by the probability. Okay. So here, after coming to know that what is meaning of the probability, that is what we are able to tell, that are we able to predict that to how much extent the event is going to occur mathematically by a number or a quantitative measurement. So there are two approaches of probability. That is the probability has been divided in two things. That is, one is experimental probability. It is also called as empirical probability. The other probability is theoretical probability or classical probability. So here, as the name itself indicate, what that is the experimental probability. It is based on a practical experiments. Here in the experiment probability, we are performing the actual experiments and we are finding the extent about that how much the probability is there to happen that event by using what, an experiments. So next approach is, we call it as a theoretical probability or a classical probability. Here we are not going to perform an actual experiment, but we are finding the extent of probability based on a set of scientific ideas. So what are those scientific ideas? That's what we are going to see in the next slide. So in the experimental probability, in the ninth standard you have learned that how to calculate the probability of any event, that is number of trials in which the event occurred or event happened divided by total number of trials. So it was about the types of probability, that is experimental probability and theoretical probability. So here already in the ninth standard you have learnt about that experiment probability, where we are performing the actual experiment and its formalized number of trials in which event occurred divided by total number of trials. In this 10th standard, totally we are been sticking to the theoretical probability. That's what we are going to see in the next slide. Okay, theoretical approach of probability. So in theoretical approach of probability, we try to predict, see what the word is used here. We try to predict what will happen without actually performing the experiment, We are not going to perform any experiment when we are been learning about the theoretical approach of probability. So experiment here, without performing experiment, we have said here what is the experiment. An operation which can produce some well-defined outcomes is nothing but an experiment. An experiment which can produce a well-defined outcomes, it means it should have a more than one outcome, and that outcome should not be predictable. That what it mean well-defined. Okay, again this theoretical approach experiments are being divided into two parts, that is one is deterministic experiment and other is random experiments. So deterministic experiments are also called as predictable experiments, whereas random experiment is also called as probabilistic experiment. So what is the actually difference between the deterministic experiment and random experiment? So this deterministic experiment, there is an experiment when this is a experiment when repeated under the identical conditions produce the same results. That's what we call it a deterministic experiment. When the experiment is performed under the same conditions, identical means same condition. When the experiment is repeated under the same condition, the results are same in this deterministic experiment. That's what he said. And in the random experiment, these are the experiments, it is repeated. When repeated under the same condition or identical condition, they do not produce the same result or outcome. That is what the difference to deterministic and random. Here when it is repeated, the same results are occurred, whereas in the random experiment, when it is repeated under the same situations, the outcomes are different. It do not produce the same results. That's okay. Let us see the examples of deterministic experiment and random experiment. So deterministic example is measuring the diameter of a coin. If you take any 1 rupee coin or a 5 rupee coin, if you start to measure the diameter of a coin, you can observe that you are going to get no matter how many times you repeat that experiment, the diameter is same. That's what we are learning in the deterministic experiment. Again, the next is determining the boiling point of the water. So the boiling point of water is constant. It's sure that you are going to get the same result whenever you are repeating under the same condition. The measuring the flow of current through the wire or circuit, that is what we are saying, that here these are what they are producing the same results under the identical condition. Let us see the examples of the random experiment. Random experiments are those which do not produce the same results what we have talked. So here he has taken the example of tossing a coin. When you toss a coin, it is sure that you are not going to get the same result every time. You may get head, sometime you may get tail. It is not sure that what you are going to decide is going to fall there. Either it may be a head or tail. You can't predict that. Throwing a die, when you throw a die, it has a 6 faces, so it's not sure that with what number you're going to get when the die is being thrown. Another example, that is drawing a card from a well shuffled pack of cards. So cards are there. If you have been shuffled properly, it is not sure that if you have picked any one of the card, we can't predict that this card is going to taken by me. So this is what we are saying, that about the random experiment, that here we are not going to get the same results or outcome when it is repeated under the same condition. Okay, so henceforth in our studies for the 10th standard, completely entirely we are going to learn about the random experiment. So let us see what is random experiment. Random experiment is an in which the exact outcome cannot be predicted. However, one can list all the possible outcomes of a random experiment. So as we have already talked about the difference between the deterministic experiment and random experiment, which we when it is repeated, we are not going to get the same result. So here what he says, that here that here exact outcome cannot be predicted. However, one can list all the possible outcomes of an experiment. That is, let us take an example of tossing a coin. If you toss a coin, we are sure, we are knowing that either it has to fall head or tail, but we are unable to predict. That's what he is saying here, that we can't exactly come to know that what is going to be fall, but we know that either one has to fall. So in another way, if you want to define the random experiment, we can define in this way also. If it has an experiment, it has to be called as a random experiment, then it has to satisfy the two conditions. And which are those two conditions? That is, the first one is it must have more than one possible outcome. If it has to be called a random experiment, the first condition it has to satisfy is that it must have more than one possible outcome. The second is it is not possible to predict the outcome in advance. It should not be able to predict what's going to happen. That's what we say the random experiment. Now these are the important terms that we have to know if we want to be clear about the probability unit. So some terms which are related to the random experiment. The first thing is trial. What is meant by trial? Trial is nothing but an action which we are performing while doing the experiment. That is nothing but trial. So repeating once again, performing a random experiment is nothing but trial. The example is, we can, for example, tossing a coin, throwing a die. That is nothing but an when if you start to flick a coin, that's what we say that trial. First trial what you get, for second trial what you got, that's what we say that trial is nothing but performance in a random experiment. For example, tossing a coin and throwing a dice. Then outcome is nothing but result of a random experiment. When you perform a trial, there is a result, and that result is nothing but outcome of a random experiment. Here, for example, if you take tossing a coin, here you have a complete observation that for the first example, we have given a first example here. For example, tossing a coin, what may occur? Either the outcome may be head or tail. That one number indicate the examples of the first one. That's what I have dotted. So here, if the second example we have taken a throwing a die or dice, so probability of having what, it may be 1, it may be 2, it may be 3, it may be 4, it may be 5, it may be 6. That's what we call it as outcome. When you throw a die, you may get 1, you may get 2, 3, 4, 5, 6. That's what we say, that the outcome is nothing but the result of a random experiment. Next is very important, sample space. Sample space means set of all possible outcomes in a random experiment. Set of all possible outcomes in a random experiment is called a sample space, and it is denoted by capital S. For example, the first thing what we have taken, that tossing a coin. What are the possible outcomes of when you toss a coin? Either you have to get head or tail. That's what we have written here. So this is a total number of outcomes which is possible. That's either it may be head or tail. Then the next is example is throwing a dice. When you throw a dice, the sample space, it means what all may occur. That is, it may be 1, it may be 2, it may be 3, it may be 4, it may be 5. That is what sample space. Don't confuse between the outcome and sample space, because here also same examples we have mentioned. Here it may be possible to get 1, 2, 3, 4, 5, 6, but here the sample space is totally what are the possible outcomes. That's what we are talking about in the sample space. Then next, event. Event is any possible outcome or the combination of outcome of a random experiment is nothing but event. Any possible outcome, the outcome which comes in the trial, that is nothing but an event. It may be in a single or it may be a combined. That what we call it as event, or else we can simply define it as that every subset of a sample space is nothing but an event. So it has been denoted by A, B, capital A, B, C, D. Let us come to the example. You will have a clear idea about what does that event means. So here first example, we have to tossing a coin. So suppose if my favorable event to get is, so getting a head. So what you will write that event, that A is the name of that event. So what is that? Getting head, that is H. So if I consider that what is the event of getting tail, then it is represented by capital B, which you will write tail. The next example we have taken, throwing a dice. Suppose if I consider that getting a 4 number, then your event will be only 4. And another example, you might get a clear idea about what is meant by even, that is getting a even number. Even number means you are having a chance of what, sample space of when the die is thrown, you get from 1 to 6. When you have been particularly stick to that, what are the events of even number means, there you have been having 2, 4 and 6. These are the called as events. It is that what we call it as subset of a sample space. Then this is a formula, that's what we are going to see in the random experiment, that probability of an event in a random experiment, that is a formula to calculate the event occurrence, that is P of E, that is probability of getting this event, is equal to the number of elementary events favorable to the event. Favorable to event means, suppose if a coin has been tossed, if my favor is getting the head, then we are going to write B of A of P of A is equal to H, and that n of E means, here n of E means, you are going to have complete understanding here, n of A. So just listen here, that n of E means number of favorable events. N of E means number of favorable events, and here n of S, already we have told about n of S. N of S, S stands for sample space, that is total number of events which are present in the sample space. So in simple way, if you want to calculate the probability of a random experiment, easily you can remember that formula, that is P of E is equal to N of E divided by N of S. Let us see that what is N of E and N of S clearly. So here we have taken the first example, that is tossing a coin. So sample space, as we have told, it will have a head and tail. And here n of s, what does that n of s means? N of s means total number of sample space. What are the possible outcomes there? Either it may be head or tail. So totally the sample space is only two ways, that is n of s is equal to 2. Then that's what we have considered now, that event A, that is if suppose I have to get my favorable event, that is I need to get a head, then what is the chance of getting a head? That's what we are going to find now. That is, my favorite event is getting head means I have taken that event as E and that event is nothing but H. So now see there, if I have considered that I have to get head, then how many events are there? There we are having n of E, that is 1. So that favorable event is 1. So here is a formula, that is P of E is equal to n of E divided by n of S. N of E is 1. This has to be E. It has A. So n of E is 1. So how much you have got here? That is n of E. N of E is 1 and n of S is 2. So what does that indicate? It indicates that I'm having a half chance of getting the head. That is the real meaning of the probability. So I'm repeating once again that it's very important part of a probability. If you understood this, every problem you can solve easily. Here, if you take the example of a tossing of a coin, we have told that the sample space is head or tail. The n of s means number of sample space are 2. Number of events in a sample space is 2. So my favorable event is getting head. So n of e is nothing but 1, because we are having H has my favorable event, which is only one event. Then our formula is P of E is equal to N of E divided by N of S. So N of E is 1. That's what we have got from here. N of S is 2. We have got from here. That means half chance we are having to get the head. You are going to get still more idea by seeing the next example. Let us take a throwing a dice. So what are the sample space? Sample space is nothing, it may be 1 from 1 to 6. So total number of sample space, it means total number of elementary events in a span sample space. Total events are, how many events are there? 6. Now what is my favorable event? My favorable event is getting a even number. So if my favorable event is getting even number, then which all are the things by which I can get the even number? If I throw the dice and if I get 2, that is also even number. If I throw a die, if I get 4, that is also even number. If I get throw a die and if I get 6, that is also even number. So that's what I am trying to say is that 2 4 6, that is 2 4 6 are those events when they occur, that's my favorable event. So how many events are here? There are totally 3 events are there. 3 events means you have to write n of e is equal to 3. Now calculating the probability of getting that event is n of e divided by n of s. That's what we are saying, that probability of getting an event is n of e. How much is n of e? That is 3, we have written here. Then what is n of s? N of s for this part, denominator, it is n of s is 6. We have got from here, that is 3 by 6 is nothing but half. So getting a even number is a half chance. 1 by 2 means half chance. So I hope the now it might be little bit clear about n of e and n of s, which we have discussed earlier. Okay, now elementary event. What is elementary event? Elementary event is nothing but each outcome, every outcome of a random experiment is called as elementary event. For example, what we have taken here, tossing a coin. Tossing a coin means sample space you are going to get head or tail. Here getting a head is elementary event, getting a tail is also elementary event. So elementary event is nothing but it is H and T, either head or tail. So this is what we call it as elementary events. Elementary events means individual we are taking. Here he has mentioned clearly that each outcome means every individual outcome of an random experiment is called as elementary event. If we have to take individual, That's what he is mentioning here. Each outcome of a random experiment is nothing but elementary event. And here one statement is very essential with reference to elementary event. That is the sum of, try to understand this point, that is sum of the probabilities of elementary event of an random experiment is 1. It means when you sum the probability of all the elementary events, the result is 1. That's what he is talking about. Let us see let us see with an example. The first example we have taken, tossing a coin. So what is its sample space? Sample space is either I can get head or tail. So already we have discussed what is the probability of getting head, that is 1 by 2. In the same way, the probability of getting tail is 1 by 2. So now probability of getting head, that is we have taken each elementary event's probability. Try to understand each each outcome of a random experiment, we call it as elementary event. Here we have taken probability of elementary event. Probability means what, to how much extent I can get high head, that is half. How much extent, what is the probability of getting tail, that is half. If you sum them, here he has used the word sum. Sum means we have to add. So here when you add, you get half plus half, that is 1. That's what he has told in the statement. It is true for all experiments. That is, if you take each elementary event and if you if you find out the probability of each elementary event and if you sum them, the result is 1. That's what he says. Try to understand by seeing the one more example here. For example, throwing a dice. The sample space is 1 2 3 4 5 6. So here, suppose if I have to find out the probability of getting an event of 1. So if I have to find out the probability of 1 means, what is your n of s here? N of s is 6, because we can get 6 different events. That is number of sample space. It means number of elementary events in a sample space. Next, my favorable event is getting 1. Getting 1 means your event is only 1. So n of 1, it means I have considered it as event has 1. So n of 1 means it is having how much? 1. The possibility of having 1 is only one time. So this we are writing as P of 1 is equal to n of 1 divided by n of s. That n of 1 is 1. 1 by 6 is the result of getting a probability of 1. Similarly, so what is the way of getting the probability of getting 2? That is also same, 1 by 6. Probability of getting number 3 when we throw a die, that is 1 by 6. Probability of getting a number 4 when you throw a die, 1 by 6. Probability of getting 5 number, 1 by 6. Probability of getting 6 number, 1 by 6. So this is all are the probabilities of getting 1 2 3 4 5 6. Now what he says that sum of all the probability of elementary events. So these are all what? Elementary events probability. Now if you sum them, if sum means what? P of 1 plus P of 2 plus P of 3 plus P of 4 plus P of 5 plus P of 6. So what you did here? 1 by 6 plus 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 1 by 6. So totally you get 6 by 6. 6 by 6 is nothing but 1. So I hope now it might be very clear about that the sum of probabilities of all the elementary event is nothing but 1. It has been asked many times in the examination for the fill in the blanks or for 1 marks MCQ, that what is the sum of the probabilities of elementary event of an experiment. That is nothing but 1. Next, very interesting topic now, that is equally likely outcomes. Equally likely outcomes, in simple words, if you have to understand, when you perform any experiment, the total outcomes, that's what you are going to have. Those events should have the equal chance of occurrence. Equal chance of occurrence, try to understand by this definition, that outcomes of a sample space is called equally likely if they have a same chance of occurring. That all outcomes should have the same chance of occurring. Let us understand by taking an example now. Tossing a fair coin. Here we have used the word fair. We have to speak, when we speak a coin we assume it to be fair. that is, it is symmetrical, so that there is no reason for it to come down more often on the same side on the other, on the same, on one side than the other. It means it should be so perfect that it means it should not be biased. Biased means, suppose if you are using unfair, he has used the word fair, right? If I have to use unfair means, will go to a person and I will be having a both side head, and if I toss and if I tell that the head is going to fall, then it is sure that it is biased and it is unfair and it is not a fair coin. And what it shows, that it is not having any chance to fall the tail. That's what I'm trying to say here. In fair coin means that it should be a coin which is having a both head and tail. And we call the property of coin being unbiased. So symmetrical means it has to be having both head and tail, and it should be unbiased. Unbiased means it should be on not it should be in a proper coin, not having a same side on the both side. And by the phrase random toss, we mean that the coin is allowed to fall freely without any bias or interference. We know in advance that the coin can only land in only two possible ways, either head or tail up. So we dismiss the possibility of landing on the edge, which may be possible. For example, if it may falls on sand, it might be fall vertically but not horizontally, if it is only in case if there is a sand, right? If it falls on sand, it might be have on its edges, it means vertically it can stand. In that case, it's not neither head or tail. We can reasonably assume that each outcome, head or tail, is likely to occur as other. We refer that by saying that the outcomes head or tail are equally likely. Equally likely means if you take a coin, it should have both head and tail, and if you flick that that you should have equally chance of what, getting head and getting tail. That's what we call equally likely outcomes. Let us see one more example. Throwing an unbiased die. Try to understand this concept, that if it is used unbiased die, right? Suppose think about biased die. If I take a die and I mark on, I will have some changes, and I will have six things on three sides, right? So what happens there? Usually a die will have a starting from 1 2 3 4 5 and 6 numbers will be there on that. If I change that, if I having a three faces, all six numbers are there, six dots are there, then what is the chance, more chances of having here? I am having a more chance of getting 6. So that's what I'm trying to tell you, that if it is unbiased, then the occurrence of these all events is equal chance it is having. That's what we say, that equally likely outcomes. So next is picking a card. Picking a card from well shuffled pack of a card. If it is well shuffled, it is sure that the picking of any card is equally likely. Equally likely means nothing but the occurrence of those event is having a same chance. That's what we are learning in equally likely outcomes. Next topic is about sure event or certain event. It is also called as in two way. It may be sure or certain event. An event which is sure to happen or occur, that is called as sure event. An event which is sure to happen, that is nothing but sure event. And the probability, it has been asked many times, what is the probability of sure event? The probability of sure event is 1. For example, if you take when you have rolled a die and your favorable event is getting a natural number. See, what are the sample space? 1 2 3 4 5 and 6. These are nothing but what? All sample space. But what you have mentioned here, getting a natural number, even if your die has thrown 1, it is natural number. If your die comes to natural number, from 1 to 6, any number it fell, it is sure that it's going to be a natural number. That's what we are trying to tell you, that getting a natural number when a die is thrown, that is nothing but a sure event. Let us see the next part, that is impossible or uncertain event. Impossible or uncertain event. An event which is not going to occur is called as impossible event. That's not going to occur, it's not going to happen. That's what we call it as impossible event. And the probability of impossible event is 0, whereas the probability of sure event is 1. Try to understand the difference. So here we have taken one example, that when a die is rolled, getting a number 7, a die is having a number from 1 to 6, there is no chance of getting a number 7. By this, what I'm trying to tell you, that my favorable event, if it is getting a number 7, then it is not sure that it's not going to happen in any way. Such events are nothing but impossible event. And very important thing, that's the next point, that is the value of probability always lies between 0 and 1. If it is nearer to 0, it means nearer to 0 means 0.3 and 0.2 and 0.1. For these all cases, what we say, that the occurrence of that event is too much less. Whereas if your result is 0.5, that is 0.5, then it is nothing but half chance of occurrence of that event is. And suppose if your probability comes 0.6, 0.7, 0.8, 0.9, so if it is nearer to 0.8, 0.9 means that event is, to some extent, it is going to happen. But if your probability value of probability is exactly 1, then that is nothing but a sure event. It is sure to happen. If it is 0, then it's not going to happen. The last part of this introduction, that is complementary event. Here, in order to understand the complementary event, let us take an example of throwing a die. When you throw a die, you know that sample space is 1, 2, 3, 4, 5, 6, and total number of elementary events in sample space is, how many events are there? Totally 6 events are there. So the next thing is, we are going to derive the complementary event formula. Let us take an example first, that getting an even number. So what are the events? 2, 4, 6. What are the number of elementary events? Number of elementary events are 3. Getting an odd number. You can call it as getting not a even number. Getting not even is same as getting odd. So complementary event, always this word will be present, that is not. So getting odd numbers are which are the numbers, that is here, that is p of, it will be written as p of e dash. E dash means not e, that is not e means not getting a even number. Which are the probabilities of not getting a even number? Not getting even number is nothing but odd number. Which are those? 1, 3 and 5. How many elementary events are there? Totally 3 elementary events are there. Let us see next. What is the probability of getting a even number? So probability of getting a even number is nothing but n of e divided by n of s, the formula. So what is n of e? 3. What is n of so probability of n of p of, so probability of getting even number is n of e divided by n of s, that is the probability of getting even number is 3. N of e is 3 and n of s is 6. N of s is 6, so that is nothing but 1 by 2. Similarly, probability of not getting a prime number is, not getting a even number is 1, 3, 5. So total number of events are how many? 3 events are here. So probability of not e is equal to n of not e by n of s, that is 3 by 6. Why? Because n of not e is 3, whereas n of s is 6. So 3 by 6 is nothing but 1 by 2. Now let us consider the sum of probability of event and probability of not e. We spell it as p of e, and we spell this as p of not e. Not e that means not getting a even number. P of E plus P of not E is equal to, this is half and this is half, so the half plus half is nothing but 1. So we have derived the formula of complementary events, that is P of E plus P of not E is equal to 1. So remember this formula we are using in the solution of problem, that P of E plus P of not E, we usually write P of not E in this way, that is equal to 1. So P of E plus P of not E is equal to 1. These are means formula related to the complementary events.